Okay, we're back with another short video. At this point, what I'd like to do is I would like to try to connect to the speaker on my computer, and I'd like to also connect to the microphone. And I'm just going to read directly from the speaker and send it directly to the microphone. And when you run this, you may want to be careful about your volume. So let's just see what happens there. You can get feedback. You will almost certainly get some sort of an echo. Part of it will be dependent upon where exactly your microphones and speakers are positioned relative to each other. And we're just taking raw input from the microphone, so there will be a good bit of static. But we'll just do this. Let's see, we need a data line, and there are two types of data lines. There's a source data line and a target data line. So source data line. And it sounds a little bit strange that the source would be the speaker, but that's the way that it was done. So I'm going to call that speaker. Okay, anything that I write to that speaker will come out of my speaker. I need to import source data line. Why is it not hinting me about this? Cannot be resolved to a type. Yeah, okay. There it is. Import source data line from Java X sound sample. That's exactly what I wanted. And now we want to say target data line. And this is going to be the mic. And we're going to need to import that as well. Import target data line. All right. So we got our variables declared. We've got a good bit of work to do inside of the constructor to initialize those. And I'm going to create one other variable up here. And this is going to be private. Actually, all of these should be private. And I'm going to say byte, and with square brackets for array, buffer. So this is just raw data, and raw data is just stored as a bunch of bytes. Each byte has 8 bits. Each bit is 1 or 0. And there's really no other, up until now we've mostly dealt with higher level data structures. Even your basic data types, ints and floats and things, are higher level than byte. Byte is about the lowest level, and we're going to do some really low level stuff at some point, but not yet. So we need to determine how big this buffer is, and just set up a few basic variables about our system. So we're going to read things in pretty big chunks. So I'm going to say, actually I'm going to put it up here. I'm going to say private int chunk size equals 4096. Actually, let's not do the equals up there. I'm going to say chunk size equals 4096. The data comes through the speakers and microphone really, really, really fast, and if we try to read it just one little piece at a time, we won't be able to keep up. So we read it in sizable chunks. We've got to set a sample rate. So I'm going to set that as a float. Sample rate. And that's going to be 44,100. And this is the number of samples per second. Okay, so the way that audio is sent to the speaker is a bunch of samples, and each sample is a number telling your speaker where the cone of the speaker needs to be at that particular moment. And those samples are fed at a rate of 44,100 samples per second. And you can change the sample rate. A higher sample rate gives you a higher quality sound, but also a larger amount of data that you've got to process. Too high, your computer can't keep up, or if you're storing it in a file, the file size gets huge. Too low, and the sound starts to sound terrible. We're going to set something called bits per sample. And we're going to use 16 bits per sample. That's 2 bytes. And that's a pretty standard thing to do. And int num channels. So you can create something with multiple channels and feed multiple sounds to a mixer at one time, and the mixer will mix those sounds together and they'll all come out of the speaker at the same time. We're only going to deal right now with one channel, so that's the way we're going to do that. Boolean signed. We're going to set that to true. So these samples can be unsigned, meaning all the numbers that are sent out there are positive, or they can be signed, meaning that the numbers have a range, and in that range is both positive and negative. And we're going to use signed numbers. Boolean is big Indian equals false. Okay, so this is talking about real low-level data storage. So there's a thing called Big Indian and Little Indian, and so the idea here is that when you type a number normally, like 256, one of those digits is the most significant digits. So that's the ones digit, the 6 is the ones digit, the 5 is the tens digit, the 2 is the hundreds digit. We would say that the 2 is the most significant digit. And Big Indian versus Little Indian has to do with whether the computer stores the rightmost digit as the most significant digit or the leftmost digit as the most significant digit. Normally we don't have to think about it, but in this case when we set up an audio line, we have to tell it whether we're using Big Indian or not, and we're not going to. And beyond just giving it a true or false, there's not a whole lot else we need to do. So we need to create an audio format, and we're going to use all these variables that I've set up here to create that audio format. So audio format, and it doesn't know what that is, so we'll have to import it. And I'll just call that format equals new audio format, and we're just going to give it our sample rate, bits per sample, our number of channels, signed, and is Big Indian. So whenever you create an audio channel, you have to tell it how to format that audio channel, all the different things that you need and want. It will not always be able to do everything that you ask. These numbers that I've picked here are really common ones, so it should be able to create this audio channel. Normally you just want to go out on the internet and find some really common things, and there are ways to probe your computer to see what it's capable of, but these should be standard. All of your computers should be able to handle this. Now we need a data line info, so we're going to say data line.info. I'm going to call this the speaker info equals new data and we'll say it comes from the source data line class. And we're going to use the format that we had created just above. And then we're going to take and actually create the source data line from this data line info object. So we're going to say speaker equals source data line audio system dot get line speaker info. And then we're going to say data line info mic info equals new data line info. This is going to be a target data line class. And we're going to use the same format because we're just going to read the bytes directly from the mic and feed them directly into the speaker. And I misspelled data line up here. And if they were different formats, we wouldn't be able to do that. Right here, when I try to get that data line from the audio system, it's telling me I have to surround that with try-catch. So I'm just going to go ahead and surround that with try-catch the way it's asking me to. And then I feel like the only two things that need to be outside of that, actually I can take all of this stuff and I'm just going to put it all in the try-catch. So that try-catch is going to be just all about opening up my two channels, my speaker and my mic. And you notice speaker is blue here. That's basically indicating that I'm assigning to some variable that lives up here. Those other variables are a different color. That's because they're local. That means they live and die in between the squiggly brackets where they're declared and used. So that's fine because I'm just kind of creating them, using them, and then they get thrown away. Because the only thing that needs to live outside of that is the speaker and the mic. All right, so then mic let's see. So we've got our speaker. So we're going to create another data line info. And this is going to be the mic info. And it's going to be a new data line info. And this is going to be a target data line. Of the same format. Okay? And then, so now once we've got our mic info, we can say mic equals target data line audio system dot get line mic info. And target data line has to be imported. Or did I spell it wrong? I must have spelled it wrong because it's not an error up there. I'm just going to copy paste. I didn't see my spelling mistake. But if I just copy paste, I see that it changed and the error went away. So I don't know what exactly I typed wrong, but I must have typed something wrong. So I've got my speaker and my mic. I have to open the speaker and mic. So I've got the data line. I've got to open the data line. So I'm going to say speaker.open. And I got to give it the audio format again. So I'm going to say speaker.open format, comma, and then I've got to tell it what my chunk size is. So I'm going to say chunk size times the bits per sample divided by 8. So what this number is basically, whenever I read from it, I'm going to read this amount, this many bytes. I've got to tell it basically, you know, how many bytes am I going to read at a time. And then I'm going to say mic.open format. Actually, it's going to be exactly the same, so I'm just going to copy paste, save some typing. Okay, and now I want to create my buffer that I'm going to read the bytes into and then write them back out to. So buffer equals new byte, and this is just going to be chunk size. This is going to be the exact same as that up there. Now, if a little bit of that is a mystery to you, don't worry. What I did is I just read somebody else's tutorial. I went to Google, and they had some sample code, and I typed in what they had and just tried it out. And I made little changes until I finally got something that worked. And this is it. And so you can just type what I've got and compile and check and make sure that you get it to work, and you'll be good. I'm going to put the next part into the next video. At this point, it will compile and run, but not do anything different than it did before. So that's opening the, whoa. Well, we'll worry about that in the next video. So that's opening the mic and the speaker.